If there is a place on Earth where all traditional laws of physics demand surrender, it is the Baypon River Gorge. Here, nature has carved a 565-meter scar into the very flesh of the planet. To put this into perspective, if you were to stack two Eiffel Towers on top of each other or place the entire Empire State Building of the United States at the bottom of the abyss, their tops would still not touch the bridge deck you are looking at. For centuries, international geological scholars visiting this place left a chilling warning on the map. The graveyard of engineering dreams. Do not attempt to build anything here ever. Yet in late 2011, a team of 3,500 human beings carrying backpacks filled with blueprints, explosives, and a wild sense of pride marched into this realm of fog. They didn't just want to build a bridge connecting two isolated provinces. They wanted to execute an unprecedented revolution of thought in the history of human architecture. This dissection of one of the world's most impossible wonders, the Baypanjang Bridge, will not focus on praises. We will uncover hidden secrets, the errors that came inches away from triggering a trillion-dollar catastrophe, the internal conflicts that nearly collapsed the project, and most importantly, the ultimate survival lesson on how humans endure when pushed to the absolute edge of risk. To understand the sheer madness of this project, we must look back at the bitter economic records of Guizhou Province before the year 2000. This was the only province in China without a single meter of expressway at the turn of the millennium. Karst topography covered 70% of its surface area. People compared Guizhou to a ceramic plate smashed into 10,000 pieces, each piece a steep limestone mountain, and in between bottomless chasms. This isolation was not merely a geographical hurdle, it was a death sentence of poverty for millions of people. Produce rotted in the fields because it couldn't be transported out. Children had to walk for 3 hours along cliff edges just to get to school. If a villager fell gravely ill, their chance of survival was virtually zero, as the journey to the nearest hospital in the neighboring province took 5 excruciating hours across deadly mountain tracks. The Chinese government understood that if they could not solve the transportation puzzle in Guizhou, the strategy to develop the West would forever remain a dream on paper. They set an impossible goal to weave a network of expressways through this multi-dimensional labyrinth. Everything went smoothly until the G56 expressway collided with the monster of the South, the Baypan River Gorge. For 13 consecutive years from 1998 to 2011, the expressway project was completely paralyzed. The issue wasn't money. It was that the gorge utterly defied any intervention from the human technology of that era. The science of bridge construction across the globe has absolute unalterable principles written into textbooks. But when facing the Baypan River, those principles became a farce. Initially, international experts were invited to consult. The most classic solution proposed was a colossal suspension bridge, similar to the Golden Gate Bridge in San Francisco. But when meteorological monitoring stations sent back the data, everyone was struck with horror. The Baypan River Gorge is not an open space. It functions like a giant aerodynamic gun barrel. The wind here does not blow in a stable horizontal direction. It is compressed between two cliff faces, creating localized wind gusts of up to 140 kilometers per hour that twist and rock upward from the riverbed. If a traditional suspension bridge were built, mechanical resonance aerodynamic flutter would rip the deck into tiny fragments, mimicking the tragic fate of the infamous Tacoma Narrows Bridge. A second option was considered, lowering the bridge's height closer to the river to escape the violent winds. But lowering it meant building support pillars over 200 meters high, anchored directly into the riverbed. When geological test drills plunged into the bottom of the Baypan River, they struck another nightmare: hollow karst terrain. The ground beneath the river was a maze of underground caves, water pockets, and bottomless geological faults. You could not find a single solid point to lay a foundation. Pouring concrete down there was no different from throwing gold bars into a bottomless pit. The project fell into an absolute stalemate for 13 years. The academic world was split into two fiercely conflicting factions. One demanded the cancellation of the road, bypassing the mountain via another path, 200 kilometers away at several times the cost. The other faction wanted to recklessly stick to the old design despite the risks. In January 2011, a young engineer named Zhou Ping stood before the evaluation board and made a shocking declaration. "We are failing because we are trying to tame nature in the old way." Why don't we turn the very hostility of the cliffs into our ally? Zhou Ping proposed an unprecedented design, an ultra-high cable-stayed bridge. But instead of placing the tower foundations in the riverbed or on the mountaintops, he decided to nail two massive towers directly onto the sheer ledges of the cliffs suspended halfway down the abyss. This blueprint was immediately met with fierce opposition from many veteran experts because it violated every minimum safety protocol. Placing a concrete structure weighing tens of thousands of tons onto a natural limestone cliff ledge. Was it genius or was it sheer madness? In November 2011, despite the skepticism, the first explosion to blast open the access roads echoed through the gorge. The life and death battle had officially begun. The first challenge was not a matter of high technology, but of raw human hands. Because the tower foundations were located on vertical 90-degree cliff ledges, no modern machinery could gain access. There were no excavators, no cranes. 3,500 workers had to strap into safety harnesses hanging suspended in mid-air to chip away at the hard rock with handheld pneumatic drills. For every meter of rock cleared, geologists had to use laser scanners to check for any hidden underground fractures. A single miscalculation by the blasting crew would cause the entire cliff face to collapse, dragging the lives of hundreds of workers down into the river below. After 8 brutal months of using human strength to subdue the rock, the two massive foundation pits were ready. But this was when the most nerve-wracking act of the drama unfolded. To create a rock-solid base for the 392-meter-high towers, workers had to continuously pour 15,000 cubic meters of high-strength concrete for each foundation. The ultimate rule was do not stop. If the pouring process was interrupted for more than 45 minutes, the concrete layers would separate, creating cold joints. Under the immense weight of the tower body and the pulling force of the cables, later on these joints would snap. For 6 days and nights straight, hundreds of concrete mixers lined up, crawling along dangerous mountain roads under a torrential downpour. The chief engineers had to stay on site around the clock using temperature gauges to ensure the concrete interior did not overheat and crack. They ate and slept at the edge of the precipice. The boundary between success and catastrophe was separated by just a few degrees Celsius on a monitor. When the two towers were completed, the next challenge arrived, the cable staying phase. Each tower was responsible for supporting half of the bridge deck via 56 ultra-strength steel cables. To run the first pilot wire across the 720-meter gap between the two tower peaks, the engineers had to enlist a specialized rescue helicopter. However, as soon as the helicopter flew out into the center of the gorge, an unexpected vortex blasted upward from the bottom of the abyss at 90 kilometers per hour. The helicopter lost control, swaying violently and coming within inches of crashing straight into the scaffolding of Tower 1. In that heart-stopping moment, the pilot made a brave choice. He switched off the autopilot system, relying entirely on his instinct and 20 years of mountain flying experience to force the helicopter down, successfully dropping the pilot wire into the hands of the waiting workers before executing an emergency turn. The entire construction site held its breath, and many burst into tears, realizing they had escaped disaster by a hair's breadth. Yet nature did not surrender easily. On the night of April 15th, 2015, when the cable system was half installed, a strange phenomenon occurred. All 112 cables began to vibrate violently in unison, emitting a terrifying howling sound that echoed across the gorge, even though the wind speed at that moment was not exceptionally high. This was vortex-induced vibration, a nightmare that could fatigue the steel and cause the cable anchors to snap within weeks. If a solution wasn't found immediately, the entire bridge structure, worth hundreds of millions of dollars, would destroy itself before it could even be joined in the middle. An emergency meeting took place that very night in the construction camp tents. The engineers made a bold decision: apply viscous damper technology, a method originally used in space rocket launch pads to neutralize vibrations. They stayed up all night designing and manually installing these massive shock absorbers at the base of every single cable. The next morning, when the next gust of wind swept through, the howls vanished and the cables stood perfectly still like tuned guitar strings. Nature was once again subdued by the razor-sharp responsiveness and crisis management of human intelligence. September 2016 marked the final phase of the project, joining the bridge deck. From both sides of the cliff, two massive steel arms extending over 600 meters stretched outwards, preparing to meet at the center point of the 565-meter deep abyss. This was the moment that would decide the success or failure of 5 years of labor. According to procedure, the final 120-ton closure segment would be hoisted up and dropped into the gap between the two decks. But when the GPS and laser positioning systems delivered the final measurements, a bucket of ice water was poured over the entire management team. The two ends of the bridge were misaligned by 3 centimeters horizontally and 1.5 centimeters vertically. For an ordinary bridge on flat ground, a misalignment of a few centimeters can be forced into place using mechanical stress. But at a height of 565 meters in a gorge plagued by unpredictable wind vortexes, these two dangling bridge arms acted like thumb levers. If hydraulic jacks were used to force them together, the steel structure would accumulate a massive amount of internal residual stress. When winter arrived and the steel contracted, this force would detonate the welds and snap the load-bearing bolts. The bridge would collapse from the inside out. The clock struck 11 p.m. The temperature dropped below 5 degrees Celsius. The countdown clock to opening day from Beijing was creating an intense psychological pressure on the shoulders of the leaders. Should they hide this error to meet the deadline or halt construction to find the cause? Engineer Zhou Ping chose a third path: confront and solve it with maximum precision. He realized that this error was not caused by a manufacturing defect but by unequal thermal expansion between the sun-facing and shadow-cast sides of the mountain slopes, combined with unbalanced tension in the cable system. An unprecedented micro-adjustment campaign was mapped out that very night. Instead of forcing the bridge deck, Zhou Ping ordered 2 teams of workers atop the towers to adjust the tension of exactly 12 strategic cables out of the 112. Each adjustment was allowed to tighten or loosen by only a few kilonewtons of force, equivalent to turning a tuning peg on a guitar string. For 18 continuous hours, the workers never left their posts. After each cable adjustment, they had to wait 15 minutes for the bridge structure to stabilize before measuring again. By 4 p.m. the following afternoon, as the last rays of sunlight pierced through the clouds, the computer screen displayed an astonishingly precise number. The error had dropped to 0.2 millimeters, virtually zero for a 10,000-ton steel wonder. The 120-ton closure piece lowered gently, fitting flawlessly like a perfect piece of Lego. Cheers, tears, and firecrackers erupted across both sides of the gorge. Guizhou's sentence of isolation was officially revoked. Looking at the grandeur of the Beipanjiang Bridge, most viewers and media outlets will focus on praising record-breaking numbers. The world's highest bridge, thousands of tons of steel, millions of cubic meters of concrete. But through the lens of modern management science and human philosophy, the true value of this bridge lies in an entirely different lesson. Blind persistence in a rigid structure is the shortest path to destruction. The key to surviving extreme adversity is dynamic adaptability. Ponder this. Why did all traditional rigid old-school bridge designs fail at the Beipan River Gorge? Because they attempted to build an absolutely rigid structure to fight against an absolutely violent nature. In such a head-on collision, victory always belongs to nature. The Beipanjiang Bridge has stood firm for over a decade amidst raging storms, not because it is harder than the storm, but because it knows how to yield to it. The engineers designed this bridge so that it could breathe and move. A colossal system of expansion joints at both ends allows the entire steel deck to freely expand and contract, shifting up to 60 centimeters every year depending on temperature fluctuations. When a 140 kilometers per hour windstorm blows through the bridge, does not stand stiffly to absorb the blow. The cable-stayed system and viscous dampers allow the deck to vibrate harmoniously within a safe amplitude, neutralizing the energy of the screaming wind before returning to its equilibrium position. This is a profound lesson for each of us in life and in corporate governance. We tend to build perfect life plans for ourselves, watertight operational structures, and stubbornly cling to them. But when life deals shifts that feel like a bottomless gorge, such as a global economic recession, a technological disruption, or an unexpected personal crisis, those who possess a rigid mindset and refuse to alter their course will be the first to break. If you want to survive and overcome immense adversity, your mindset must mirror the structure of this bridge. You must have anchor foundations of core values rooted deeply into the solid rock, but at the same time you must possess the flexibility of cable stays and the co-expanding capability of expansion joints to adapt to any shift in the surrounding environment. Learn to transform external pressure into internal balancing momentum. On December 29, 2016, the Beipanjiang Bridge officially opened to traffic. Look at the real-world numbers to see a historic transformation, a journey between the two provinces of Yunnan and Guizhou that once took 5 hours traversing deadly mountain tracks now takes exactly 4 minutes. For the farmers of Guizhou, those 4 minutes mean their produce reaches supermarkets in Shanghai and Shenzhen on the very same day, perfectly fresh. For businesses, it slashes logistics costs and transit time by 97%. Within the first 24 hours of its opening, images of this legendary bridge garnered over 500 million views globally. Guinness World Records officially honored it as the highest bridge on the planet, but titles like highest or largest will eventually be overtaken by time and newer technologies in the future. The only thing that will never be obscured is the unyielding human spirit cast into every fiber of steel and every block of concrete of this structure. When the workers finished the final weld, they affectionately called that day the gorge disappeared forever. The gorge did not disappear geographically. It vanished from the human consciousness of isolation and fear. If right now you are standing before a bottomless gorge of your own, when everyone around you and perhaps even your own logic says, that is impossible, remember the story of Beipanjiang. Do not waste time blaming the hostile terrain, and do not wait for flat ground to begin your journey. Learn to stand firm and cast your roots directly onto suspended cliff ledges. Accept margins of error. Adapt flexibly to the storm and keep building your own path. Because in the end, humanity's greatest bridges are not built with finance or stone. They are shaped by the longing and the never-surrendering will of the human spirit.